We are solving two-step equations today. So the first thing on there, you're blank. The goal, and this is a reminder from yesterday, but the goal is to always get the variable alone. That's always going to be the goal no matter how many steps in an equation we are solving. The goal is always to get the variable alone. So some of the steps to do that. Number one, make sure you focus on the side of the equation that has the variable. So that's where sometimes you might see us draw a dotted line through your equal sign. We are focusing on the side that has the variable only. Step two is we're going to remove or get rid of anything that's not directly attached to the variable first. This is typically going to involve either addition or subtraction. That will make a little bit more sense when we do the examples at the bottom. I'll make sure to point out what I mean. We also have to make sure that we use inverse operations or opposite operations. You can write either inverse or opposite, whichever makes more sense to you. And then make sure that whatever you do to one side of the equation, you must do to the other side. We have to keep our equation balanced or we will get the wrong answer. And finally, make sure you always check your answer by plugging in the value you found for the variable and solving. Algebra, which is what solving equations is honestly really great because you should be able to know by as soon as you finish that problem whether you get it right or wrong based on plugging it back in. It's one of the few subjects in math where you can actually check your answer. So moving on to actually practicing this. My first problem, I have 26 equals c over negative 2 plus 5. I want to focus on the side that has my variable on it. So if it helps you to put in that dotted line at your equal sign, that's fine. And I notice that my variable's on the right side, so that's what I'm looking at. I want to get rid of whatever's least attached or furthest away from my variable first. So if you notice, c is directly on top of negative 2. It's attached to it, whereas that plus 5 is a little bit further away. So we're going to get rid of that plus 5 first, and we're going to use opposite or inverse operations to do that. So to get rid of a plus 5, we are going to subtract 5. And whatever I do to one side, I do to the other. A positive 5 minus 5 gives me 0, or they cancel out. And I am left with c over negative 2. And then I have my equal sign. Make sure you draw that equal sign in. And on the left side, 26 minus 5 is 21. Now I only have one final thing to get rid of on the side with my variable. It is c over negative 2. C is written in a fraction, and a fraction represents division. So in order to get rid of it, I'm going to do the opposite of division, which is multiplication. And I do need to multiply by a negative 2. I'm getting rid of that whole number. And I'm going to do it on both sides. So on my right side, a divided by 2 and a times by 2 cancel each other out, leaving me with just c. And on the left side, I have negative 2 times 21. If you need to just set up 21 times 2 off to the side, you could do that, but you would get 42. And the last thing I need to do is check my sign. Here, since I'm using multiplication, I can use my good thing, bad thing trick. So I've got a negative 2 and a positive 21. A bad thing happens to a good person. Therefore, I am sad, or my answer is negative. My answer is negative 42. Now I can always check this answer just to be sure. So that means I could plug it back into my original equation. So instead of c over negative 2, I could have negative 42 over 2. And follow my order of operations to solve. In my order of operations, I would have to do division first, and negative 42 divided by negative 2 is positive 21. And then I still have to add my 5, and 21 plus 5 is 26. So this equation that I have, 26 equals 26, since I have the same number there, I know I did it correctly. My answer is good. Moving on to number 2, I have 14 minus g equals 73. Now this one may not look like a two-step problem, but you'll be able to see in a minute. First thing is focus on the side with the variables. So if you need to put in your dotted line, do so. My variable's on the left side this time, so that's what I'm going to focus on. And I want to get rid of the thing that's furthest away from my variable, usually involving addition or subtraction. I'm going to get rid of that 14, and it's a positive 14. I'm always looking at that sign in front. Since it's a positive 14, the only way I'm going to get rid of it is subtracting 14. I need to bring it to 0, and I'm doing it on both sides. 14 minus 14 cancels out, and I still have a minus g or a negative g left over. That's where the 2 part comes in. And on the other side, 73 minus 14 is what you are solving. And if you needed to work that out off to the side, you could, but you would get 59. And here I am not done. I don't want to know what negative g equals. I just want to know what g equals. So we've talked about this a couple times. There's no number in front of g, but when there's no number written, I can always assume it's a 1. So this is like a negative 1 times g. In order to get rid of that negative sign or that negative 1, I can use division. I can divide by negative 1 on both sides. Negative 1 divided by negative 1 gives me nothing, or g. And 59 divided by negative 1. A good thing happens to a bad person. I am sad. It's a negative 59 is my answer. Again, I could check that by plugging it back into the original problem. I could do 14 minus a negative 59. I just plugged in that negative 59 for g equals 73. If you notice when I read that, I said minus a negative. So I want to rewrite that with keep, change, opposite. That's a rule we learned a long time ago. We keep our 14, change that to addition. The opposite is a positive 59. And when I saw 14 plus 59 this time, because my signs are the same, I would get 73 equals 73. I know my answer is correct. If I did not get the same number on both sides of that equal sign, I would be wrong and I'd have to go back and check it. Moving on to number 3, negative 1/2 x plus 1/3 equals 5 3/4. Here I want to focus on the side that has my variable. So put your dotted line in if it's helpful. The x is on the left side, so I'm only looking at the left side right now. I've got a negative 1/2 and I've got a positive 1/3. I want to get rid of what's furthest away or not directly attached to my variable, and that would be my positive 1/3 or my plus 1/3. The 1/2 is right next to it. So I'm going to get rid of that plus 1/3 by subtracting 1/3. On the left side, they're going to cancel out, leaving me with negative 1/2 x in my equal sign. On the right, I actually have to solve this problem, and it's a little tougher than normal because I have fractions. Whenever I am adding or subtracting fractions, I do need a common denominator. So a good one for 4 and 3 would be 12. So this is going to become 5 and 9/12 minus 4/12. All I did so far was get a common denominator. 9 minus 4 gives me 5. My denominator stays the same. 5 minus nothing gives me 5. So I've got negative 1/2 x equals 5 and 5/12. In order to get rid of that negative 1/2, it's a number next to a letter. Whenever I have a number next to a letter, I don't care if it's positive, negative, fraction, decimal, or whole number. If I have a number right next to a letter, that shows multiplication. So the only way to get rid of it is dividing by negative 1/2. They're going to cancel out on the left side, and on the other side, I literally have to solve it. I'm dividing by a negative 1/2. Because I'm dealing with fractions, I need to rewrite this as improper. So 5 times 12 gives me 60. Again, you could work that out off to the side if you didn't know it. Plus the numerator is 65 over 12. And then I still have my division with a negative 1/2. When I'm dividing fractions, I have 3 steps. I can keep, change, flip, or another way to say that is multiply by the reciprocal. So this becomes 65 over 12 times negative 2 over 1. When you multiply across the top, 65 times 2 is 130. 12 times 1 is 12. We can save our sign for the end because I do still need to simplify this. So 12 can go into 30. And again, you could figure this out off to the side if you needed to, but it can go in 10 times. 10 times 12 is 120. So to get to that 130, I have 10 left over with 12 at the bottom. That is still not in simplest form, so I have to go into my other box a little bit because I'm running out of room. But my whole number is still 10. 10 and 12 can both be divided by 2. That's going to leave me with 5 over 6. And now, finally, I need to check my sign. So I'm looking back at my division problem here. I had a positive divided by a negative. A good thing happens to a bad person. I am sad. It's a negative 10 and 5, 6 for number 3. Again, I could check that by plugging it back in for x and solving, and I would see that I did get the correct answer. Moving on to number 4, we are almost done. Figure out the side that you're going to focus on. The variable's on my right side. Put in your dotted lines if you need it. On the right side, I have a negative 15.3 and an m is in a fraction with 5. I want to get rid of the thing that's not directly attached to my variable or further away from the variable. Again, this usually involves addition or subtraction. So the thing that's furthest away is my negative 15.3. To get rid of it, I'm going to add 15.3 to both sides. On the right, they cancel out, leaving me with a negative m over 5. That negative sign is still there, and the fraction is still there. On the left side, maybe you need to rewrite it if you need more space, but what you should notice is you have different signs. When you have different signs, you are actually subtracting. So I'm going to do 45.75 minus 15.30. I'm lining up my decimals. 5 minus 0 is 5. 7 minus 3 is 4. Bring your decimal down. 5 minus 5 is 0. 4 minus 1 is 3. And my final thing that I've got to check is what do I have more of? And I have more negatives, so it's a negative 30.45. The last thing I need to do is get rid of that negative sign in the 5. M is in a fraction. A fraction represents division. So the inverse or the opposite of that would be multiplying. I'm going to multiply by a negative 5. That will get rid of the 5 and the negative sign. On the right, they cancel out, leaving me with just m. And on the other side, I actually have to multiply. Again, you might need to set this up. So I am multiplying that 30.45 times 5. 5 times 5 is 25, carry your 2. 5 times 4 is 20, plus 2 more is 22, carry the 2. 5 times 0 is 0, plus 2 is 2. And 5 times 3 is 15. You need to move your decimal over. You had 2 numbers behind the decimal, so I'm going to move it 1, 2 spaces to make it 152.25. And the last thing I'm going to check is my sign. I had a negative number times a negative number. A bad thing happens to a good person, therefore, a bad thing happens to a bad person. Therefore, I am happy. It is a positive 152.25. Again, plug it back in for your variable and solve if you want to check your answer. Finally, number 5, Frank is a car salesman. He is paid a base rate of $500 a week plus $250 for every car he sells. If he made a total of $1,250 last week, how many cars did he sell? Write and solve an equation. Similar to what we've talked about earlier this week and last week with our writing expressions and equations, is I need to pay attention to what I know and what I don't know. And the question can usually help me out with what I don't know. The question is asking, how many cars did he sell? That means my variable is going to represent that amount. So I'm going to use C for cars, but C stands for number of cars sold. Next thing I'm going to do is go through and figure out what my ultimate or ending value is along with any other important piece of information. So he is paid a base rate of $500 a week plus $250 for every car he sells, and he made a total of $1,250 last week. So my total, my ending amount, that's what it's going to equal. That's one of those phrases that we used before. It's all going to equal $1,250. Now, to get to that $1,250 or that amount he made, he was paid a base rate of $500. That means no matter what, he's getting paid $500. Plus, so I'm literally going to write a plus sign, $250 for every car he sells. So if he sold one car, he'd make $250. 2 cars would be $500, and so on. So that means I need to take that price or that amount per car and multiply it by my number of cars or my variable. Now I've got my equation written. That was step number 1. Step number 2 is to solve it. So draw on your little dotted line if that's helpful. But I am trying to figure out what C is going to equal. So I'm focused on the left side of my equation. I need to get rid of the thing that's furthest away or not directly attached to C, and that would be the 500. It's a positive 500, so the only way I'm going to get rid of it is by subtracting 500 on both sides of that dotted line. On the left side, they cancel out, leaving me with 250C equals. On the right side, if you need to rewrite it somewhere and figure it out, you're going to do 1250 minus 500, and you're going to get an answer of 750. Finally, we still have to get rid of that 250, and it is right next to the variable, which means it's showing multiplication. So to get rid of it, I'm going to do the opposite, which is division by 250 on both sides. On the left, they cancel, leaving me with just C. And on the right, 750 divided by 250. You could set up long division if you need to, or you could count up by 250s or try different multiplication problems. But you would find that 250 goes into 750 3 times exactly. So when I'm asking how many cars that he sold, you would tell me he sold 3 cars. So again, there were 2 parts to that problem. There was writing the equation, which we did first, and then there was solving it, which we just finished. Please make sure you check in these notes with your teacher and ask any questions that you have.